Let's do number 2 of exploration 1, which says, find a power series that represents 1 over 3x and give its interval of convergence. Now, what we've been doing in exploration 1 is remembering that a over 1 minus r can be represented as a power series of a plus ar plus ar squared plus dot 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 out to my general term of a r to the n, and then we go out to infinity, and that this converges for the absolute value of r less than 1. And so the technique that we've been using in the first part of this exploration is to manipulate our function so that it looks like a constant over 1 minus something. And then we take that something and we substitute it in our power series every time we have an r. So let's go with what we've got here. We're trying to find a power series for 1 over 3x. And I'm going to do something a little different for the hint, which is I'm going to put the 1/3 in the numerator. And then the hint says this is 1 plus x minus 1. But this isn't quite a over 1 minus something yet. So I need to use the same technique that I did in part D of the first part of exploration 1, which is I'm going to leave my 1/3 up here, but I'm going to make my denominator 1 minus negative x minus 1. And now I can say that a is equal to 1/3 and r is going to be equal to negative x minus 1. And now I'm going to substitute those things into my power series up here. So I'm going to have 1/3, and then I'm going to have 1/3 times r, which is going to give me a negative 1 there. And I'm going to have 1/3 times x minus 1. When I square r for the next term, my negative sign is going to go away. So this is going to be plus 1/3 times x minus 1 squared. When I go to my cubic term, when I cube that negative 1, it's still going to be negative. So I'm going to have minus 1/3 times x minus 1 cubed. And then I'm going to go and write down my general term. And I'm going to pull out that negative 1, and I'm going to make it negative 1 to the n over 3 times x minus 1 to the n. And then, of course, this is going to go on to infinity. I'm almost done, but I still have to find the interval of convergence. And I know that this will converge for the absolute value of r less than 1. And in this case, my r is negative x minus 1. So I'm going to say that the absolute value of negative x minus 1 has to be less than 1. Move this down a little bit. So when I use my absolute value signs, that's going to tell me that negative 1 is less than x minus 1 is less than 1. And I want to get that x all by itself, so I'm going to have to add 1 to each side of my inequality, and that's going to give me 0 is less than x is less than 2, so my interval of convergence is going to be 0, comma 2.